be really easy.
Pick on Tim.
Tim?
It's about the boat.
Well, we always pick on the same people.
I know. Taking. Do we have a volunteer?
Well, I will volunteer to do it for the time when I'm not talking.
And I will be there too, so, to fill in the blanks. And for anyone, I know that a lot of you are shy, including a lot of people for whom English is not your native language, but that's the beauty of Etherpad, is if you get more people on Etherpad, then it simply becomes everybody is filling in the holes of everyone else, and it's a whole lot less stressful. So the more people we have on Etherpad, as long as you're not like doing malicious things, the more people we have, the better. It can get really amusing though. I highly recommend it for everybody who even wants to consider maybe getting more involved in IETF. It's a wonderful thing. I will meet you on Etherpad. Okay, David, take it away. Yeah.
Stuart?
Okay, because this is a joint session, there are 2 blue sheets per each of the things. There's a Homenet and a Dnssd. Oh, should I talk into the microphone? There's Homenet and Dnssd on each of these, and so if you're going to stay here for both, please put your name on both. That would be much appreciated. Okay. David, can you get started?
And Barbara, we didn't put your name on both, though.
I put my name on one of each.
No.
No, Stuart has the other one.
All right, let's get started. So we're going to start with a half hour of Dnssd. And so getting started. So it is Monday. This is the note well. It's a very big slide, and I'm not going to keep it up long enough. But if you haven't read the note well, please actually look it up in your favorite search engine and actually do read it. You, just by being here and saying things, you have requirements relating to patents, for example, that you need to be aware of. And also the IETF has a code of conduct that we will be enforcing. So if you're not aware of what's in that code of conduct, please go inform yourself. But it's pretty reasonable stuff. Just be nice to everyone around you and everything will go great. So a few reminders. Anytime you go up to the microphone, please state your name clearly so the minute taker can take it down. Please review our documents so we keep progressing them and we make sure they are the highest quality output possible. And please sign the blue sheets that are going around right now. So we have, in case you're searching for the links, you can pull up these slides in the tools. These are some links mainly for people that are not in the room. And just a usual reminder, we have a GitHub organization, and any draft author that would like their draft on there to facilitate collaboration should just let us know, and we'll get that set up for you very quickly. So our main goals for today's sessions are to get an update on our current documents, to discuss some more early work, and discuss kind of where we're going with all this, and also our privacy efforts. So here's our agenda specific to Dnssd, not to Homenet. So our first half-hour session has these 3 items, and our second session later today will be discussing privacy. Would anyone like to bash the agenda? Going once, twice. All right, success. And Stuart, you're up.
By the way, I have the status for all of that.
Oh, do you want to do that now, or?
No, we can do it after Stuart.
Okay.
Should I use the clicker?
Yes. Yeah. There you go. This should work.
Thank you, David. So I'm here to give some updates on our documents. The first one I'm talking about is Service Registration Protocol, which is a reminder a way for devices offering services to use a variant of DNS update to record that in the network as an alternative to using multicast. Right now, the primary application of this is something called Thread Mesh Networking, which is an initiative that came out of Nest. Their home thermostats and smoke detectors use this. It's built on the same IEEE 802.15.4 radio that things like Zigbee use. The difference is Zigbee is a vertical proprietary network architecture for everything from the addressing, the naming, and the application protocol that runs on top of it. Here at the IETF, we believe in the longevity of IP-based applications because even when the hardware changes, the same application software carries on running. So that is my strong predisposition. The people who started the Thread group have the same philosophy, and they are running 6LoWPAN IPv6 over these IEEE radios. They are 1/4 megabit per second, roughly 10-meter range, similar in range and speed to Bluetooth Low Energy, but much more IP friendly. So standard IP software runs over these without having to be rewritten. What the Thread group is adding is mesh networking, because 6LoWPAN just defines one hop IPv6. And the Thread group also defines the onboarding commissioning process, how you give a device the credentials to be on the mesh. What they don't have right now is any firm specification for service discovery, other than a sort of hand-wavy thing saying, well, just use multicast like Ethernet does. We know that multicast is inefficient and slow and unreliable on Wi-Fi. The same is true, even more so, on these Thread mesh networks. When you have a mesh and you're forwarding the multicast multiple hops to reach the whole mesh, when potentially only one device is interested, or maybe no devices, is even more wasteful than Wi-Fi. So we have been proposing using SRP. The great opportunity here is Thread is a brand new thing. There is some limited deployment with the Nest products, but it's certainly not as widespread as Wi-Fi is. So we have an opportunity to define something good from the start, and we don't have a backwards compatibility legacy issue to deal with. If we could go back in time 20 years, maybe we should have done this for Wi-Fi as well, but we didn't. So the transition for Wi-Fi will take longer, but we have a great opportunity now. The last Thread all members meeting was 2 weeks ago in Switzerland, and I was there pitching these ideas to try to get support from the rest of the Thread community. I can report that that was very successful. They have green-lighted this for as a work item to take on. That doesn't necessarily mean it will be part of a future specification, but if we're successful, then it will. So that's a great opportunity, I think, to start Thread mesh networking out right from the start, instead of starting with multicast and then realizing it doesn't work and having to retrofit something on and then having a legacy support issue. Part of what we want to have here is Thread border routers that implement this SRP server, and ideally make that a mandatory requirement that to be a certified Thread border router, you have to implement this. Of course, there's some politics involved there in getting that language into the specification, getting everybody to agree that that's a requirement. But that's what we're going to try to do. So anybody in the room who's interested in working on this, we'd love to have more implementations and more collaboration on the document. Second document to talk about is the roadmap. This needs to be updated, and it was not, because I was away working on this Thread group meeting and putting together all my materials to pitch these ideas there. This is intended for the time being to be a living document that's updated to be the table of contents for all the other documents, so to speak. I would love to have co-authors join me on this. This is not, absolutely not intended to be a one-man show. I'm often up here at the front of the room talking about things, but I don't intend it to be that way. So if there's anybody interested in joining in, please don't be shy about doing that. I hope Ted can hear us. I know Ted was going to add some comments as well. So
He's on the jabber.
okay.
As in, he's not saying anything, but he's there.
Okay.
Oh, well, there.
Here he
there's
goes.
Ted.
Wild Ted.
I love the three-letter thing. Ted Lim. Hi, Ted.
Well, hi there. I don't have a huge amount to say, but just regarding the SRP stuff, I've been doing a ton of work on the SRP stuff over the last, 3 months. And, the first thing to say about the spec is that it seems to be proving itself to be a good spec. I've definitely found some gaps in the spec which need to be updated. It's at this point, it's getting to be pretty mature, though. So I'm going to come out probably before the next IETF, not super before the next IETF, because I've got a lot of work on my plate before the next IETF. But I'm going to come out with a new version of the spec. And at that point, I'm going to propose that people give it a serious read and we do a last call on it, because this is a real thing that at this point is, I've got running code. There's going to be an open source version of this that's out and available both for IoT devices and for regular, hosts. It would be good to get people to read over it and see if they can see gaps that I missed. I mean, there's a couple of really obvious things that I missed. Like, for example, the document doesn't actually say how to remove an SRP update. And it also doesn't say what to do if you're just advertising a host but no services. So right now the document would actually reject an update of that sort, which I think is actually probably wrong, because then you don't actually get feature parity with Dnssd over multicast DNS. So things like that are still in progress and need to be updated. And it would be really awesome if anybody's interested in doing updates to this. I'm hoping that I'll be able to get the source code out, so if people want to hack on it rather than writing their own from scratch, it'll be very adaptable. The source code that I'm working on right now has an adaptation layer, so you can make it run on whatever hardware you want by just adding about 10 functions of that provide things like send a UDP packet and wake up at this time kind of stuff. So that would be great. I think that's about all I have to say about it. This is the main thing I've been working on for the last couple of months, so I don't really have any new updates for the other stuff, but obviously that's still, particularly the relay document is still hanging fire and needs some work. So is there anything else I should say about this, Stuart?
No, that's good. I just wanted to give you a chance to update, because Ted and I were together at the thread group meeting in Switzerland and actually did a demo using some prototype border router devices from Eero, from Linksys, and the Google Nest hubs. And that demo was successful, and we showed different vendors' products interoperating. We had an iPhone running the HomeKit app, talking over Wi-Fi to the Linksys border router over Thread to a simulated HomeKit accessory, a light. I guess it wasn't simulated, it was a real LED light. It just wasn't a very bright one. It's a little development kit with a surface mount LED. But in terms of software, that is exactly a HomeKit controlled light. And on the same thread mesh, Google was showing an Android phone using the Google Nest software to lock and unlock a door lock. And to us at the IETF, that's not particularly remarkable. To the IoT vendors, seeing different vendors' products work at the same time on the same mesh was absolutely mind-blowing. So we got a lot of interest because right now, if you buy IKEA smart LEDs, you need an IKEA hub. You buy Philips Hue bulbs, you need a Philips hub. You buy a Comcast home security system, you need a Comcast hub. They're all Zigbee, but they don't talk to each other. So the idea that a single border router from any vendor could actually support multiple different applications at the same time from two other vendors, that was remarkable. So we are working to push forwards on this and demonstrate that this is real, because that's what we want. We want a world where Thread is like Wi-Fi. You can buy one access point from pretty much anybody and expect that all your devices will work with it. Yes.
So, yeah, thank you for doing that.
State your name, please.
Daniel Migo Erickson. So this is a great work, and I commit to review the next version of the draft.
Thank you.
I'm not going to review the code, but the draft, yes.
Okay, thanks.
And thanks.
Oh, Stuart, one thing I wanted to mention about the work that Daniel is working on, actually, and Daniel, this is something that you might want to think about, is that in order to do like Dnssd, well, actually, never mind, I'll do that in the Homenet thing. It's not really a Dnssd thing.
All right, just wait 13 minutes.
Yeah, it'll require taking your hat off and putting the next one on.
Next document, the relay, as Ted said, this needs an update. Ted and I have both been busy. Would love to work with others on this, and I'll make this call again. I have heard people say that this is the Ted and Stuart show, and that's not our intention. And if it seemed like we didn't welcome other people contributing, I apologize for that, because that was never our intention. There was a time not so long ago when Ted was not working on this, and he got interested and started working on it. So if Ted can do it, we're definitely open to other people getting more involved too. And then the final update I have is on push notifications, which is in the same cluster with the discovery proxy. And this is all reviewed, last call, ISG approved, ready to be published. And as part of this group, you may know we have an old thing that we developed at Apple like a decade ago, which is the UDP-based variant of push notifications. Now, experience with this showed that something that maybe we should have known, but it's a lesson that we learned, is that building your own hacky protocol on top of UDP is rarely a good idea. And that's why push notifications is defined to run over TCP. And we retired the LLQ document, made a new draft, and we've implemented it, and it's been reviewed, and it's great. And when this was published, I asked the independent stream editor to publish the LLQ document as an informational document just for the historical record, that this is the old thing. If you see these packets, this is what they mean, but with a clear forward reference saying, don't implement this, do the new thing instead. And in the process of doing that, he said, I see an IPR disclosure on this. And I apologized to the working group in the IETF. That was totally my fault. This was a decade ago. I had totally forgotten about it. So I have asked Apple Legal to basically apply that same IPR disclosure to the push notifications draft, offering that patent under the same terms, because that's our intention. What we said 10 years ago applies now. Big companies, things move slowly. But I'm hopeful, cross fingers, that literally any day now we will get that disclosure in, and that can unblock this, and then all three documents can go ahead and get published. Hopefully by the end of the year. That would be nice to get 2019 dates on these. So that is the final update on that. Thank you.
Thank you, Stuart. Any questions?
Go ahead. And here's the summary of what Stuart just told you. There's your waiting for DNS push, which is waiting for the patent IPR declaration. And we have the privacy and security requirements, which are in working group last call. Is that right? That's what the status said.
Yes. Yeah. The privacy requirements we'll be discussing at the privacy session at 6:10 tonight.
Right. And the SRP document is still a working group document, and comments are welcome and encouraged. That's the word. Yeah. Yeah, next up is okay. So I did send an email to the list because we have on again, off again discussed, do we ever want to recharter? And so these were some points I kind of grouped some of them together that Tom Pusateri had brought up as things maybe to consider. There was very minimal discussion. I think there was one email that said, yeah, maybe, I don't know. That's just my summary of it. And so I'd like to, ask maybe here if any of these call out to you and, really resonate and like have your name attached to them or something, and you'd like to see us recharter. I think that's a no.
So the idea here is our current charter for Dnssd was really focused on losing the dependency on multicast. And so in particular, like the hybrid proxy was the main work item, which is about to be published. Once all that's done, and like the documents that Stuart was talking about, once we wrap all those up, one possibility is we declare success and close the working group. Another possibility is there are other topics that some people find interesting, so we recharter to incorporate those into our charter and work on them. But in order to do that, we need people who are willing to pick up that work. That's why, like, if these are potential ideas for things we can work on, but if we don't have individual contributors interested in working on those, then they won't happen.
So let's hear from Daniel.
Yeah.
Okay.
Daniel and then Ted.
So Daniel Migaud Erickson. I think, well, if you're willing to recharter, I think maybe we should have a scope that is also, merging the Homenet activities related to the naming. So
is that item number 1 or something else?
I don't know. The ongoing work within the Homenet, I would say.
Well, so we wouldn't recharter to take over Homenet, right? So what are you, sorry, can you elaborate on what you're thinking?
Well, the thing is, I believe that we need to the work being done in Dnssd is quite close to, they are not independent from what is being done in Homenet. So it might be helpful we have everything in one place. If that's simpler, but related to naming, I think that's maybe if we need to recharter. But I'm not asking to recharter. So
thank you. That's a good point. All right. Ted.
Yeah, so one point about what Danielle actually just said is that in order to do, so remember we have this thing called the DNS discovery proxy, Dnssd discovery proxy. It looks like an authoritative server, but it doesn't actually retain any state. It's a stateless it's got a cache, but essentially it's a stateless authoritative server. And one of the things Daniel's working on is how do we set up a secondary so that people aren't hammering on the primary server to get answers to questions all the time. And I think that there's actually a problem to solve there in that if we have a Dnssd discovery proxy, it would be nice to be able to do something that has that effect, but it's not going to work using zone transfers. It's going to have to work using DNS push. So writing a document that talks about how that works might be worth doing, hopefully after actually trying it. So I think there is actually some work to do there. Continuing on that, we're not done with the SRP stuff. And by the way, that's a continuation of the moving from multicast to unicast. There's clearly more work to do on that, if only just finishing the document, but possibly also after that. We haven't finished the relay document. I think that it's important that we finish that. So I don't think we're quite ready to say we're done yet. Maybe we're getting there. That's not to say that we can't recharter, but I just want to make the point that we are definitely not quite done yet.
Oh,
And then,
absolutely, Ted. Sorry, I didn't mean to say that we're done and we should all go home. Just when those items are done, and I think the items you described fit into our current charter.
Yeah.
And saying when those, and even like that new document that you just mentioned, I would see that as pertaining to the current charter. And so when all of those are done, would be that situation where we might close down.
Yep. Yeah, and by the way, unicast many discovery is actually a solved problem. I'm not convinced we need to do any work there because that's how Dnssd works generally. You ask for a PTR record for a service, and it gives you a list of all of the known services on that PTR record. I mean, it gives you a list of PTR records for each of the services that provide, for each of the servers that provide that service. So I'm not, if there is a problem to solve there, it's not clear to me from the bullet item what that problem is.
Okay, thanks, Ted. So Ray and then Tim.
I'll come on to Ray Hunter here. I'll be speaking later on to my own slides. But just to back up on Ted there, I think there's a big gap at the minute on implementation experience around naming, how this all fits together. And I'm not sure we need a document on it, but we certainly need running code.
Thank you. That's really good feedback.
Tim Wattenberg. I'll actually second what Ray just said about working code. I think that's quite something which might be something achievable. I think there is quite some code, and as Stuart presented some time ago, it's also, for example, available in the GitHub repo. But yeah, there might be more than one implementation, which might be nice. That's my first point. The second point would be that, as we said earlier, the current charter is kind of focused around reducing multicast traffic. And I think what we are seeing right now, for example, also with what Stuart presented earlier with this threat model, let's call it like this, and also other techniques, LoRa or whatever. So there's still a need for service discovery, maybe in domains which are not specific to this multicast problem, but where still we need to kind of solve the idea of how is service discovery implemented in those areas. And I think much of the work which has been done in this working group could be applied for that, but probably there are some ideas which which we might to think through in this perspective as well, and that might be actually something. It has been a time that I read through the charter, but maybe this is something where rechartering would be good to specify or to make a point that it's not only about multicast but also other transport mechanisms where service discovery is needed or wanted.
Thanks, Tim.
I'm hearing a common theme, people talking about more code experience. I'm really happy to hear that. So I'm going to make a suggestion. We've been using the hackathon time at the IETF meetings, but it's often just been me and Ted or me and Ted and Tim. Maybe we can make a plan for the next hackathon to have a concrete list of things that we're going to work on. So if anybody is interested in and willing to contribute to that, send an email to the list or privately to me and Ted, and let's make an actual plan of some concrete things we want to achieve at the next hackathon.
Stuart, can I give you the action item of coming up with that original list and posting a list of things to work on the next hackathon and putting it on the list for comment?
Yes, I will send out a suggested list, and I welcome input from other people about what they think are the priorities to work on.
Thank you, Stuart. All right, so we are pretty much out of, we have 1 minute left. So thanks. I think the current documents are in good shape. So we're gonna leave that at that. I'm gonna quickly plug, we have our second session on the third session today at 6:10 p.m. where we'll be discussing privacy, and specifically today, if you use MDNS, Dnssd, the names and everything and the services are in the clear. and we're looking at ways to make these things encrypted, so an attacker who's on the same network as you doesn't know what services you're searching for or the name of your devices. So if you think that could be interesting, please come back. I think it's in this room at 6:10. All right, and I think we're going to switch over to Homenet.
There you go.
So the JavaScript is on, or okay, we're doing this as a second one.
So, yeah, is it possible to continue on JavaScript? But simply on the Homenet Jabber? That would be much appreciated. And the note taking is now going to move over to the Homenet Etherpad. Yay! Can you tee up a few more things, and I'm going to open up the Etherpad, or, well, I guess you're on Jabber. Okay. Oops, I pushed the wrong button. My bad. Oh, it's all messed up now. Hate it when that happens. Oh. No, I can do this.
Just the MeetEcho folks let us know that they're going to keep the Dnssd Jabber for Homenet. So maybe we can keep, or can I JavaScript just keep an eye on both? Is that okay? Thanks.
Yeah. The same note well applies. Go figure.
No, even better.
And we've just discussed the same blue sheets apply. And if you haven't signed the blue sheets, where are the blue sheets? And anybody need blue sheets? And again, there are two sets of blue sheets for each blue sheets. There's the Dnssd blue sheets and the Homenet blue sheets, and please sign both. Okay. No. Okay, so first up is going to be the Homenet naming architecture. This is the agenda. Wait, we have to give people a chance to hit bash. Anybody want to bash? Look, nobody wants to bash. Just real quick before we start your stuff. I shouldn't do that. Anyway. Just take it. It's okay. No, I'm just going to deal with it. It's just okay. So I did just have, kind of like the other one. Here's the status. There are 3 drafts. So right now we're going to be talking about, so the first one is just sitting there hanging out in Babel land. That is, it's waiting for the Babel reference to be done, and it's just waiting and waiting. And we don't have anything to do with that. The next one, Daniel did just update, and he's going to be discussing that. The HNCP that we'll be discussing today doesn't have a draft, actually. And then there's Ted's draft, which hasn't been updated in a while, but it is awaiting implementations. And again, the hackathon that Stuart mentioned is valid for that as well, hopefully. Oh, look, it's Ted Lemon. You want to let him in? Maybe. Well, Stephen, you need to push it harder. There you go. Okay, Ted.
FYI, the Homenet, the simple Homenet naming stuff, there is actually, I've been doing some implementation work on that. It's a little bit farther in the rearview mirror than 3 months, but we have some running code that does little pieces of that, and I think there's been other work that's been done on that as well. So there is actually ongoing work. It's not just, it would be nice if somebody did something.
Okay. And now we're going to move on.
Quick comment I wanted to make about HNCP. For the thread group work that Ted and I have been looking at, there is this question. What if you have multiple thread border routers on your network, and the thread network is a sufficiently dissimilar technology to Ethernet and Wi-Fi that it doesn't make sense to bridge it? So today, quite often with Wi-Fi, you just bridge it with the Ethernet. You have multiple access points. It's all bridged together. With Thread, that isn't an option. So there has been, in the existing members of the thread group, there's been some hand-wavy statements about, oh, HNCP solves that. I think that's a very strong candidate, and we need to actually implement it. So
okay, and the HNCP discussion is part 2, and we've got some slides on that. And so thank you for teeing that up, but you're just a little premature, Stuart. Now we're going to talk with Daniel.
But regarding the status, there is another draft that is looking at DHCP options to provision the outsourcing infrastructure. We have to see how valid it is when that's going to be done. So, outsourcing Homenet authoritative naming service. So, well, it's an old draft. Next slide.
Is it not?
Oh, yeah, that's me. Yeah. So we basically rewrote the document. I think pretty much the full document. What changed is that we specified, the protocol that is used in order for the between the Homenet way authoritative naming, the naming authority, and the outsourcing infrastructure. We reviewed the names, the terminology as well. Ray did an implementation of that. So some of the design choices have been driven by the implementation. And there is a concrete interest in deploying it. So the next step is, I think, my expectation is that we review the draft, try to see if we can clarify some things between us. And then it's, in my opinion, is going to be pretty much close to working group last call. So this is the high level picture. So, but that's fine. That's fine. Our things is on it. So,
Okay.
Doesn't make the slide less complicated.
So I'm not going to touch any button. What is to have a
Pointer?
a pointer?
Show with your hand.
Okay.
Yeah, you're on camera.
So
Take it off the hook.
okay, easier. So so this is a starting point from the naming architecture within the Homenet, and so these are all the things a little bit influenced by the simple naming architecture. These are the functionalities that we are dealing with, but the one we're going to talk about regarding outsourcing is really this one. So you have a public zone, and it needs to be outsourced so that any resolution here on the public Homenet authoritative servers can be done on the internet. So the idea is that within your Homenet, for people on the internet, they will not reach your home networks, but instead you're able to outsource this to Cloudflare or any cloud provider.
Just a quick note from remote, it's quite hard because the people cannot see what you're pointing at. So
Okay.
maybe you also say what you're pointing at so that they can follow.
Okay, yeah. So should I repeat? So this is a starting point of I'm not pointing anything, so it's
I think I can use
but
the
someone,
mouse.
but is that me or?
That's me.
Okay.
Tell me what you want to point at.
So there is nothing to point. This is a global picture of what we're moving on for the network, the naming architecture in the home networks, and the outsourcing. The related part of the outsourcing is just one piece of that, and it's the one represented in red. So where you have a connections between a Homenet authority and the distributed master, as well as the one represented in black here, the Homenet authoritative servers, and maybe some relations with the resolver, which is represented in blue. So, next step. Next slide. So, the Homenet naming authorities, what it basically does, it builds a zone for the Homenet that is expected to be reached from outside of the internet. So it's basically the zone of device that you expect to be published on the wild internet. We're using DNSSEC. So the idea is that the Homenet is generating its key, keep its key very secret, sign the zone, and push the zone to the outsourcing infrastructure. So the only thing that is it's got quite a simple mechanisms, but what we would like to have is a way to automate that and to make that easy to configure so that it can actually be deployed at scale, which means on various Homenet routers. Yeah, so you have the key for the DNS, and because the Homenet authority is going to upload the file to outsourcing infrastructure. It needs to be authenticated, those two parties. So we're using another set of keys, which is only restricted for the authentication. So the resolver. So when you're in your Homenet, you want to access also the domain names that are being published outside on the outsourcing infrastructure. So suppose you're using Cloudflare. Cloudflare is hosting for you your Homenet zone, and you have connectivity disruptions. So you want to be able to reach from your Homenet your names that are www.example.com or let's say nas.example.com. You want to be able to reach in within your internet Homenet, even though you have connectivity disruptions. How you can do that? Well, it's basically having a way to reach what is in the public zone inside the Homenet. So you could have an Homenet authoritative service that is doing that for you. Okay, so that's the big picture. Well, I mean, it's more a zoom. So the important concepts are. Oh yeah, but there is a camera here. No, I should not move. Yeah, okay. So I can read here. So you have the Homenet naming authority. He has a public zone, and is outsourcing the zone on the outsourcing infrastructure. So you have a control channel, synchronization channel, and the endpoint where he's pushing that zone is called the distribution master. Yeah, the distribution master. And so this distribution master is then responsible for distributing this zone again within the cloud infrastructure, but it's not really much the purpose of the home network. This is really the purpose of the cloud provider. So what we focused our draft on is to define how you can control, configure the distribution master, the relations between the HNA and the distribution master, and how you can sync your zone between the two. So, so that's the main part. And as I mentioned, you need to have an authoritative server inside your Homenet in case of internet connectivity disruptions. And this is where the Homenet resolver is going to probably resolve inside the internet. So you can definitely see a small problem here is that your resolver that has to resolve .example.com is not going to go on the internet. It is going to go on the Homenet authoritative servers, most probably, in which case it needs to have, it needs to be provisions and configured to do that. It's not going to be done magically. Ted.
Daniel, can you talk just briefly about why it's useful to be able to get an answer about something that's on the Homenet when the Homenet connectivity isn't present? I'm not saying it's not, I'm just curious what your rationale is.
So the question is, why do we need to have the Homenet authoritative servers? I mean,
no. The question is, suppose the Homenet doesn't have connectivity to the internet.
Yeah.
Why is it important to be able to get a question answered about a service on the Homenet during that period? I'm not saying it's not, but that's the question.
Well, the reason is that, well, it's a requirement from the initial Homenet document, but it's because if you want to access your video server or your music server, you don't have the connectivity to access it from outside. So, but when you're connected inside, you still need.
So it's while you're at home, not while you're away.
Yeah.
Thank you.
But Michael Richardson here. So Ted, but in addition to answer the question a little bit differently, the reason why you don't wish to use videoserver.home.arpa is because the TLS certificate won't match up, and then you'll get all upset and frustrated, and then you'll learn to click the right bad warnings that they don't want you to click on. So if you did have security, then we'd like the name to resolve correctly within the Homenet, even when you're not connected, so that you can do that. And in particular, one of the names that you probably would like to reach is your home router, so you can find out why you don't have internet. Or fix it, right? Does that make sense to the room?
Sure. Should I try to vote?
I just wanted to say what Michael said. It's so that you can have one device that moves across the boundary to always use the same name. So if your mobile phone's connected to your NAS and there's some security on there, you always use the same name, whether you're connected to the Wi-Fi or whether you're connected to 4G.
So next slide. Is that fine? Do we have any questions regarding this or no? So the two channels. So we have the control channel, and so I think the important things to realize about this control channel is that basically we're exchanging some configurations between the two. So how we do that? We're using a special way to do that. Is that the information is carried by DNS messages. So it's important to realize that we're only using the DNS format, and they are interpreted in a certain way by the other hand, both hands. I mean, so when the HNA wants to retrieve some parameters, he's using an AXFR query. And when he's willing to push some informations, is using a DNS update. So the reason we did not use HTTP or JSON object is that when we were working with DNS libraries, all the DNS libraries have these messages, and so it was much easier, much lightweight to use this way to carry the information. Then the synchronization channel, we're using a primary-secondary relation, and distribution channel is almost out of scope of the Homenet. So securing the channels. So the control channel is authenticated and encrypted using TLS. So we basically did, a common way to secure DNS exchange is to use a TSIG. But we removed that. We did not really consider this because, well, you have the symmetric keys that have to be renewed. and provision. So we basically only use TLS. A question that was raised is that, do we really need to protect with TLS the synchronization channel, given that the content of the public zone is expected to be public, and it's signed with DNSSEC. So this is one of the comments we received. So I'd like to see if there are any ideas, any thoughts on that.
So Daniel, there's a draft in DeepDrive on XFR over TLS now. That's relatively recent. Is that what you're considering using here?
Well, so yeah, everything is over TLS. So I maybe I have to dig why we need a draft on. Yeah, that's yeah.
Okay.
It's basically what we. Ray.
Yeah, Ray Bellis, ISC. Sorry, can you go back one slide, please, Daniel? On the DS sending for the DNSSEC, could I suggest you please look at using CDS instead of DS? Because that already has the specific semantic that it's for a child to publish its DS record to its parent. So in conformant servers, they can automatically handle taking CDS from the child and pushing it up into their parent zone rather than needing some separate out-of-band mechanism.
Yeah, so this will be the purpose of the outsourcing infrastructure. And so what we are saying is basically that we leave that to the outsourcing infrastructure. They could use the CDS or any EPP mechanisms.
Yeah, but a published CDS record already means, please send this to my parents.
Yeah,
that's exactly what that's for.
Yeah.
So
okay, so within, when I provide the Homenet zone, I'm signing it, having the CDS in that.
Yeah. Yeah.
Okay.
So yeah, send CDS rather than DS, and it should just work.
Yeah.
So just as
with support of registrars.
Yeah, it's not in the draft, but thanks for.
So as a time check, I think we're down to 8 minutes.
Okay.
You have a question in the queue.
So Ray, do you want to do this or you?
Ray is.
Just wanted to reply to Ray Bellis. Definitely use CDS for ongoing operations over the synchronization channel, but and there's a standard for that, not implemented already, using CDS records. Fully aware of that, but the problem is we've got to establish trust for the initial operations, and you can't do that on scale using the existing mechanisms. So what we do is we publish a DS record over the control channel, and we're using the certificate on the TLS to establish the initial trust for the DS record. Does that make sense? Why we're doing that?
So I think these are good things to discuss on the mailing list. And I also had a question myself about things like factory reset, but maybe that's in the draft, and I just need to read the latest version.
Factory reset also covered by the same mechanism if the certificate establishes the trust.
But so again, I think those are good things to discuss on the list.
Welcome,
Ray. I think you're up next anyway. So do you want to just stay there?
Sure.
Well, you've got one more slide.
No, I'm gonna skip it.
You're done?
Okay.
Yeah.
So let's try and take discussion of this to the list.
Just a quick introduction. You've probably never seen me before, though. I've been working with the IETF since about 2010 or so, 2009, I believe. I first started taking part. I don't tend to travel nowadays because try to minimize the CO2 and also like staying at home as well. Anyway, but you can always get me v6ops@globalstate.net for IETF work. I'm basically a network consultant, more operational type person than a coder, and this I do pro bono for the IETF. And I actually earn my money as a program manager, believe it or not, because techie stuff doesn't pay. Anyway, next slide. That's enough about me. Let's talk about the technology.
Sorry.
The question, and Stuart raised an excellent point about HNCP, is HNCP evolution, is when I posted to the list in the last few months about HNCP, the response I got was, "We're done." And that's definitely what I'd like to talk about in my few minutes here, is are we done with HNCP? Because what I've been doing is I've been hacking with HNCP, as well as implementing the previous draft that we talked about, and identifying missing what's in HNCP, both from the simple naming draft that Ted wrote and the front-end naming delegation that written together with Daniel and others. And I'm coming to the conclusion that we are missing stuff in HNCP. So what I've been doing is I've looked at, for example, how it fragments on the network, and I've put in a patch for the existing implementation to reduce the number of IPv6 fragments. So any questions on this particular slide?
None in the room.
Okay, next slide then. So the point Barbara made is I haven't actually put any draft on at the minute, and there's a reason for that, is I'm not sure what we want to do in the work group for HNCP and whether there's any appetite to do it. So that's why I thought we'd just put these questions out there, is both of our drafts need more functions than are currently available in the implementation of HNCP, gateway to other technologies.
Oh. Ray has, I'm not sure if Ray is still.
Okay, so there are gaps in what HNCP is doing for us, and for example,
Ray, we lost you for a second, but you seem to be back now.
Primary and secondary servers, configuring up gateways and other specialist functions that we might want to run on the Homenet router. And the point I'd make is that the HNCP in the RFCs that have been published, they assume or appear to assume that all nodes are created equal. And there's no actual configuration or tie-break mechanism to say that actually node A is a bit bigger than node B, so it's better to run these central functions on A and B. So what I'm asking is, do we want to keep all of our nodes equal and go for a fully distributed environment for Homenet, or do we want to encourage specialization of some services? And some things like not unbound external route, I've done some work on that, and it took 25 megabytes of overlay. Now, that's not big for a NAS box, assuming you've got a NAS box in your Homenet, but for a Wi-Fi router, that's enormous. So I've got a TP-Link router, and that comes with 8 megs of flash, and most of that's taken up with the core of OpenWRT. So if you put all of this extra stuff on top, and don't actually need to enable it, for example, a central DNS server, you've suddenly made your small box very expensive by the addition of $4 of extra flash, which doesn't sound a lot of money, but in the cutthroat world of end devices, $4 is a lot of money per device. And then I come on to the question of how do we want to do this? Do we want to have TLVs for each function? Or do we want to come up with a draft, something like embedded SRV RRs into a TLV so that you can elect a master and then bootstrap the service? And this would come to something like Stuart talked about, where you would want to put in an SRV record for a gateway device and then elect the gateway devices, depending on whether you want to elect one or whether you want to elect multiple gateway devices. So that's what I'm asking for feedback on, and I spoke very quickly about those slides to give some time for feedback and questions.
Okay, so we have Daniel in the room, and Ted, I think, is still in the queue.
Okay, so Ted.
It's not clear to me how to switch like this, but we'll try hit the button a couple of times and see what happens. So there goes Ray, and here comes Ted. Yeah.
Okay. So a couple things. First of all, I'm really delighted that Ray's been working on this. I've been following the work that he's been doing, but I haven't really had time to participate because I've been working on the SRP stuff. So I'm hoping that we'll have a chance to work on this before the next IETF, and if not, then in that, at least in that zone. I think that it's a bit of a red herring to worry about flash space because I don't think that that's really the direction that things are going at this point. If we were to require that routers provide enough flash space to do this stuff correctly, and if there were demand for this functionality, I think that the difference in the price of the flash, first of all, I don't think it would be $4 for the part. I think it would be quite a bit less than that because the amount of additional flash isn't that much. But secondly, I think that we're the day when
So this,
when
is where
the
Ray's getting
margins-
back in queue and Ted.
Did you lose me?
Come back.
Internet connectivity is wonderful. Anyway, so I think worrying about footprint is probably not that important. That said, I think it is certainly the case that there will be primary and secondaries, and we should figure out how to do that.
Okay.
So.
Thanks. We have a couple of people here in the room in the queue and 0 minutes, but so if we were brief, that should work.
Michael Richardson here. So I'm going to agree with Ted for the reason that if you look at the market for 100 meg plus fiber to the home type devices, they are not the the $20 devices. They are upwards in hundreds of dollars, and that couple bucks for extra flash is probably okay. It's only in the little doohickey devices that we stick in our pockets and bring to the IETF with us that it's a $6 event.
So Daniel, did you want to?
Yeah, I just want to say that's great feedback, but I would say that
so Ray, we can let you just finish off there. We're kind of out of time, but
Homenet, so we're going to have to produce basically 3 different images. We're going to have to come up with a heavy image for the big devices and a light image for the small devices.
Okay. And I think with that, we're out of time. Hopefully people will take these topics to the mailing list and we can discuss them there. Thank you all.
And Dnssd is in this room at 1810, which happens to be 6:10, depending on if you're 12-hour, 8 or 24-hour clock. Yes. That actually went well.
Yeah, half an hour was a little, like we could have done another 10 minutes maybe, but
Yeah.
Well, nor did I, so you're not the worst person.
Yeah, I won't yell at you for that. I'll yell at you for everything.
Stephen will.
Also, we need to have another about